Today we're going to be talking about angle measures. First of all, let's talk about what is an angle. So when you see an angle, you usually expect to see something like this. And when we name an angle, it will have 3 points on it. Okay? It will have 1 point on each of the sides. Okay? And it will have 1 point at the vertex. Okay? So let's talk about how we would write this if it was in a problem or a question. First of all, we would use our angle symbol. It looks a little bit like the greater than, less than sign. And if you have to type it in on a keyboard, that's what you use. And we have 2 ways we could name this angle. We could name this angle as BCD, okay, with the 3-letter name. The order doesn't matter as long as the vertex is in the center. Okay, so this has to be the center, and that's because it is the vertex. Okay, it's that point. Or you could name this using a 1-letter name, and that would be angle C. Okay, and again, that is named for the vertex. So you can name this angle, because it's one angle, by either 3 letters with the vertex in the center, or with 1 letter, and that 1 letter has to be that vertex letter. So it would have to be C. You couldn't call it angle anything else. Okay. Next, we need to talk about what are the parts of the angle, like what makes up an angle. So let's draw ourselves a new angle here. And when we're looking at this, we said we have, use the same letters here, we have 2 sides. So let's talk about those sides first of all. Each of these sides is a ray. A ray is going to start at 1 point and go continuously in one direction. Okay? When we name a ray, it's going to be very similar to how we name a line or a line segment. We have to start at this end point. So we're going to start with C. And we're going to name 1 point that it goes through on its way to infinity. When we do that, we are going to draw a line with 1 arrow over it. And so the arrow is always going to point to the right because it's saying, hey, this is where that end point is, and then this is the direction it's going off into infinity. Okay, so we have 2 rays here. One is that top line. The other one starts at C again and goes through point B. And again, it gets a line with an arrow over it. Okay? So these are the names of the 2 sides of our angle. The other part we already named here, but in case you didn't write it down, this is the vertex. Okay? And then we have 3 places that point can be on an angle. So I'm going to just draw mine again. If you still have room on yours, you're welcome to draw on the same angle. Let's see, so that was B, C, and D. Okay. And so the 3 parts of the angle are the angle itself. And so if I was going to choose one of these 3 points, I could say point B is on the angle. Okay, so on the angle. If I put a point in here, we'll call this point A. It is on the inside or the interior of the angle. So point A is on the interior or in the interior of the angle. That's a little messy. Let me write that a little bit more neatly. It is in the interior. Okay. And then we also have all of this space on the outside here that goes around the angle. And so that is the exterior. So if I had a point E, we would say E is on the exterior of the angle. Okay. So interior is like you have an interior designer who decorates the inside of your house. Exterior, if you have an exterminator, they spray around the outside of your house, so you can remember that's outside. And then you have on the angle itself. Next, we're going to talk about how do I measure this angle here, the number of degrees on the inside. How am I going to do that? So we're going to look at a tool we use in class called a protractor. This is our protractor, and you're going to notice a couple of things. First of all, every protractor is going to have either a set of crosshairs or a little hole down here at the center, and that location is where the vertex of the angle goes. So when you go to line up your angle that you want to measure, you would put the vertex either in the little crosshairs, and crosshairs look just like a little plus sign, or you put it, like you put the little hole exactly over that vertex. Okay? Whichever direction this line is, or this ray, excuse me, it's going to line up with the straight line on your protractor, and you have to think about this as pointing to 0. So you have two options here. You're going to notice that this outside edge has numbers that start here or start on the other side, and then they go up. And so this is the end of this side. And then you also have numbers on the inside, right here, and they start down here at 0 and go up from there. So we're interested in using this little inside portion because we are starting at 0 down here and we are going up from here. So you just want to be sure you're using the right part, and then you're going to line it up. And so you look and you would say, oh, look, this lines up right here, and that is right at the 75 because it's halfway between 70 and 80 degrees. So it would be 75 degrees. Okay, and we'll practice using those in class a little bit tomorrow. We also have some different types of angles, and our first one most of you are familiar with is a right angle. A right angle, oops, there's the bell. So a right angle is 90 degrees. It has to be exactly 90 degrees, not 90.5, not 89.9, 90 degrees exactly. We also have angles that are less than 90, so anything less than 90, starting at 89.5, is going to be an acute angle. And this is less than 90 degrees. Anything bigger than 90 degrees, so that starts at 90.1. Anything larger than 90 degrees would be an obtuse angle. And I'll put a degree measurement. Right up here, sorry. Greater than 90 degrees. So these are the three ways that we classify triangles. And I'm not sure if you're familiar with that term, but classify just means that we are putting these triangles into groups. Okay, we classify things in science, we classify things in math, and it just means to put them into groups. So we're going to practice tomorrow in class some, and you're going to put angles into groups by whether they are 90-degree angles, which are right angles, or if they are acute angles, or if they're obtuse angles. Okay, I just realized I did not write the word right up here. So those 90-degree angles, again, are right angles. Next, we need to talk about what happens if we cut an angle in half. So if I have this angle, and we're going to say that this is angle A, and I'm going to tell you that to start with, angle A's measurement is, we'll say, 80 degrees. And I'm not measuring it, so it's not, it's not particular. If I were to draw a ray that started here at this vertex and went straight up, and I were to tell you that on this side it is 40 degrees, and on this side it is 40 degrees, then this ray that we just drew here, this would be an angle bisector. And you might remember that when we were talking in the last section about line segments, that we said we had a segment bisector. that cut a line segment in half. This is an angle bisector because it cuts the angle exactly in half. And so that's going to be all for today. We'll do some practice in class tomorrow. And thank you for listening. I hope you have a lovely afternoon. Goodbye.